Okay, Assalamualaikum and good morning. So today we will see a few tutorials. So the title may be like similar with undergraduate. We are talking about the viscosity and so on and so forth. But the idea is we go a little bit complicated with by changing the situation. Okay. So this is tutorial number 11. Estimate the viscosity of nitrogen at 66 megapascal and 49 degrees Celsius and compare with the measured value of 45 micropascal second. So according to the textbook, 66 megapascal is high pressure, cannot use low density method. So what I want to show here is for fluid, there is one parameter which is very unique called viscosity because for density and also for the mass and so on, the parameter uh, can be used for solid and also for liquid and also for gas. But for viscosity here, this is the only parameter that can only be used in fluid. So mean for gas and also for liquid. Okay, so I think previously you know that viscosity is it has two type of viscosity. One is kinematic viscosity and another one is dynamic viscosity. So normally for liquid, so we could measure viscosity using the viscometer. So if you have liquid, so you could measure the viscosity. That's why there is no problem if you have a lot of type of liquid, whether the temperature is changing or the temperature is increasing and so on and so forth, because liquid can be tapped into your beaker and then you could measure the viscosity. The problem is when you have gas as your element, as your research element. So because gas is, you cannot just have, you cannot take gas and do the viscosity check. So normally people will do the estimation by using this kind of calculation, because sometimes it is not easy to compress gas to certain temperature and certain pressure. Okay, so from this table you could get from the textbook. So this idea is actually previous researcher already measured the certain type of common gas here at representative condition. So we have the critical atmospheric or the representative pressure. So and then we have the temperature here. We have the representative at certain temperature here. So and then this is the parameter that we get from the table. The critical temperature is 227 degree R Rankine. So the critical pressure is 33.5 atm atmospheric pressure, and the critical viscosity is 1.8 times 10 to the power of minus 5 Pascal second. So and then what we need to do is we need to change the Rankine unit into the Kelvin. So this is the equation. So we get 126.11 Kelvin. And then we calculate the reduced temperature. So for example, this is the reduced temperature. So because the question is 49 degrees Celsius. So we calculate in Kelvin. So we have the 49 plus 273 divided by the critical temperature, so we get is 2.553 Kelvin. So then we calculate the pressure. So we have the critical pressure is the 3.5 times, this is the 1 atm, which is 101.3 kilopascal. You can use 101,325, so we get this value. So we have 3,000,000 3.3 megapascal, and then we could calculate the reduced pressure as 25.336. So all these parameters then can be estimated. So your answer can be estimated by using this table. So you could see this in the textbook, the explanation how the idea of this one. This we have two axes. One is x-axis here is about the reduced temperature. So it is the ratio of the representative temperature over the critical temperature, and then the reduced dynamic viscosity, which is the ratio of the representative uh, viscosity over the critical viscosity here. And then what we calculate just now, the PR here means the reduced pressure is actually given by this line. So because you could see the title here, reduced viscosity versus reduced temperature for several value of reduced pressure. So as I said, this is actually the idea of curve fitting. So previous researcher are doing a lot of thing about this. He prepared the situation, and then we compare what they get with the what we want to do. Okay, let's say according to the what we have right now is the reduced temperature 2.553. So you could imagine we have 2 here, we have 3, and 2.55 maybe around this one. And then the reduced pressure is 25, so we get the line here. So if you want to do, for example, if you have 15, for example, there are no line about 15, but you need to do is you need to do the ratio calculation here. So for example, if this 5 and this is 10, so might be at the middle point here, it is 7.5. So if you want to get 15, so maybe it is around 15 here, 20 is here, and 25 is here. So what you need to do is you need to draw another line here. Exactly the same curve with the line of 25 and 10. So that is the idea. So and then you bring the point here. So until it has 25 degrees Celsius, and I'm sorry, 25 reduced pressure here. So and then you go to the left side, so you will get it is around between 2 and 3. So maybe it is around 2.5 and so on. So you will get it is 2.5 reduced viscosity. So and then we estimate the viscosity by using this calculation. So the reduced ratio is 2.5. So it is equal to representative value of viscosity divided by the critical viscosity. So we could calculate what is the value of mu here. So it is equal to 45 mu Pascal second.